If you sit down to write a simple calculator application, you can do it alone, in a single file, with very little planning. But if you try to build a platform like Netflix or a global banking network, the rules change entirely. You are suddenly dealing with millions of lines of code written by thousands of engineers working at the same time. If you throw all that code into one massive, unstructured bucket, the technical hurdles appear immediately. A single minor update in one corner of the program can force the entire system to be rebuilt from scratch, making every deployment agonizingly slow. Then the human brain hits its limit. Without a clear map, the codebase becomes impossible to reason about. Developers spend more time trying to untangle the overlapping logic than actually writing new features. And because large platforms require massive teams, everyone ends up stepping on each other's toes. Without strict boundaries, engineers overwrite each other's work and introduce cascading bugs into the product. Raw code, no matter how cleanly written, cannot scale indefinitely on its own. Without an underlying structural blueprint, it collapses under its own weight. Look at this chart mapping the cost of changing software over time. That red line represents a project built without a plan. At the start of development, everything feels deceptively fast. The line stays flat because you can add features freely, cutting corners and moving quickly without immediate consequence. But as the codebase grows, it hits a breaking point. Adding a single feature suddenly takes weeks instead of hours. Bugs multiply. The cost of making any change spikes violently upward into unpredictable chaos. Now look at the Scion line emerging. This represents a system built with good architecture. The growth in cost remains smooth and linear, remaining predictable even as the application scales. This data shows why software architecture is a mandatory investment. It is the only reliable way to prevent rapidly escalating technical debt from completely stalling a project. Architecture sits right in the middle, acting as the bridge connecting the requirements, what the users actually need, to the design, how the code will actually be written. The first step in building that bridge is defining the system context. We draw a strict boundary separating what lives inside our system from everything that exists outside of it. Once we have that boundary, we perform decomposition. We slice the monolith into smaller, specialized components. In an online store, you isolate user accounts, payment processing, and the product catalog. But separating code is only half the job. We have to define the relationships. Establishing the precise communication protocols and data flows connecting them is often more critical than the components themselves. By combining careful decomposition with strictly managed communication paths, we create a system that developers can actually comprehend and one that can scale safely. There is a persistent idea in development that a great system should be built to do absolutely everything, remaining entirely open-ended for any future scenario. Building for every possible future use case creates infinite complexity, pushing a system to stretch in too many directions at once until it shatters. Real architecture forces teams to make calculated trade-offs. It balances required performance and features against very real physical limits, budget constraints, and technical realities. These decisions cascade down through every level of a project, from high-level enterprise strategy through the business domains, into the software components, down to bare metal servers. Great design is a series of intentional choices. It requires deciding exactly where flexibility matters, and exactly where strict, immovable boundaries are required. This brings us to the people responsible for drawing those boundaries. The role of a software architect is built around making decisions and communicating trade-offs, rather than simply writing elite code. Look at this central node holding 4 competing lines. This represents the daily reality of an architect. Users demand high speed, developers want clean code, managers require low costs, and system operators insist on absolute stability. Balancing these demands requires a continuously evolving, highly collaborative process. It relies on constant negotiation across the entire team to find the right path forward. Software architecture is the ultimate tool for managing both human and technical chaos. It organizes teams and technologies to transform chaotic ideas into scalable digital realities.